Welcome to the DIY Honda Garage channel. DTC B1176 indicates a fault in the fuel level sensor, which is responsible for measuring the fuel level in the tank and sending that information to the gauge on your dashboard. The fuel gauge sending unit, located within the fuel tank assembly, plays a vital role in accurately displaying fuel levels to the driver. A short in its circuit can cause incorrect readings, potentially leading the driver to run out of fuel unexpectedly. In the 2008 to 2012 Honda Accord, this DTC occurs due to an electrical issue that may result from damaged wiring or a malfunction within the fuel gauge sending unit itself. Spurious readings from the gauge can be particularly concerning, and this DTC is essential for ensuring your fuel system operates correctly. Therefore, addressing this trouble code is crucial for reliable vehicle performance and safety. The DTC B1176 pertains to the fuel level sensor circuit, which may indicate a fault within the fuel gauge sending unit or its wiring. The fuel gauge sending unit, situated in the fuel tank, utilizes a float mechanism that moves with the fuel level and sends an electrical signal to the gauge. When a short circuit emerges, it can disrupt the signal transmission, leading to incorrect or erratic fuel level readings. The sensor is critical for informing the driver about fuel availability, and any malfunction may lead to unforeseen fuel starvation. Additionally, if there is any wear or damage to insulation around the wiring, it can cause shorts leading to the activation of this DTC. Thus, locating and assessing the integrity of both the sensor and the associated wiring is fundamental in the troubleshooting process. Several factors can lead to the activation of DTC B1176. Firstly, worn or missing insulation around the wiring harness may expose the wires, potentially creating a short circuit. This condition can lead to fluctuating readings or complete failure of the fuel gauge. Secondly, a short in the wire circuit itself can either occur internally within the wires or between the wires and the vehicle's ground. Thirdly, the fuel gauge sending unit may be malfunctioning due to internal damage or wear, causing it to send incorrect signals to the gauge. Each of these potential causes needs to be examined during the diagnostic process to identify the specific issue leading to the code. A systematic approach will ensure that the correct cause is pinpointed, allowing for effective repairs and restoring functionality to the fuel gauge system. The presence of DTC B1176 can lead to several observable symptoms. Most notably, the fuel gauge may display inaccurate readings, either showing more fuel than is actually present or failing to register fuel levels entirely. This erratic behavior can cause confusion for the driver, who may not know how much fuel is in the tank. Additionally, the check engine light may illuminate as a result of the issues with the fuel level sensor, providing a warning that something is amiss with the vehicle's fuel system. In some cases, there might be a delay in the gauge responding to changes in fuel levels, which can create further uncertainty. Therefore, recognizing these symptoms is the first step in diagnosing and addressing the underlying issues pertaining to DTC B1176. The first step in troubleshooting DTC B1176 is to clear any existing diagnostic trouble codes using the Honda Diagnostics System, HDS. This system provides technicians with the necessary tools to communicate with the vehicle's onboard computer. Once the codes are cleared, it is essential to turn the ignition switch to the lock position, 0, and then back to the on position, 2. This step is crucial as it allows the onboard systems to reset. Following the ignition cycle, it is important to wait for at least 30 seconds to ensure that all systems are fully initialized. After this waiting period, the technician should check for any reoccurring DTCs using the HDS. If code B1176 is indicated, it signals a persistent issue requiring further investigation. If not, it may suggest an intermittent failure or a transient circuit issue that is no longer affecting the system. In the second step of the troubleshooting process for DTC B1176, begin by turning the ignition switch to the lock position, 0, to ensure safety while working on electrical components. This precaution minimizes the risk of electrical shock or accidental short circuits during diagnosis. Next, disconnect the 4P connector from the fuel tank unit, which is the component that directly interfaces with the fuel gauge sending unit. This unit is located in the fuel tank and is responsible for providing accurate fuel level readings. After disconnecting this connector, the technician will then clear any DTCs again using the HDS to reinitialize the system state. Following this, the ignition switch should be turned to the on position, 2, again, and a waiting period of at least 30 seconds is necessary before checking for DTCs once more, which will help isolate if the fuel tank unit is the source of the issue or if further diagnosis is required. After disconnecting the fuel tank unit connector, the next critical step is to check for any diagnostic trouble codes using the Honda Diagnostic System, HDS, again. This step verifies whether the previously indicated DTC B1176 is still present after isolating the fuel tank unit from the system. If DTC B1176 continues to be displayed, it confirms that the problem resides in the circuit associated with either the gauge control module or the wiring leading to it. If the code is not present anymore, it indicates that the issue may have been intermittent or is no longer affecting the circuit. This approach aids the technician in narrowing down which component might require further examination or replacement, necessitating a focused effort on resolving the identified issue. Proceeding to the fourth step of the troubleshooting procedure, once DTC B1176 is confirmed as active, turn the ignition switch to the lock position, 0, once again for safety. The next task involves disconnecting the gauge control module's 32P connector. This component processes the signal received from the fuel gauge sending unit and translates this information into the display on the dashboard. Disconnecting it enables the technician to isolate potential causes from this part of the circuit. After disconnection, the technician can systematically check for continuity and ensure that the correct flow of signals is maintained without obstruction or faults. This is critical in pinpointing whether the gauge control module itself is faulty or if the issue is rooted elsewhere in the wiring or connection. In the fifth step, the technician must check for continuity between terminal number 27 of the gauge control module's 32P connector and the vehicle's body ground. Continuity indicates that there is a complete circuit between these points, and an absence of continuity would suggest a disruption that could be causing the DTC. This step determines whether the ground connection is functioning properly, which is essential for all electrical systems, including the fuel gauge. If continuity is present, it confirms that the wiring is intact and helps narrow down the possible causes of the DTC. Conversely, if there is no continuity, it suggests there may be an issue with the wiring itself, such as a break or fault, creating an open circuit that would need to be repaired to restore proper function. If the continuity check indicates a successful connection to body ground, the next action requires identifying and repairing any shorts to ground in the wiring between the gauge control module and the fuel tank unit. This step is crucial because shorts can disrupt the signal from the fuel level sensor to the gauge, causing incorrect readings and possibly activating DTC B1176. Should the wiring exhibit visible wear or damage, it may require replacement to ensure a reliable electrical connection. Conducting a thorough inspection of the wiring harnesses for any exposed wires, particularly in areas that are subjected to movement or friction, will reveal potential problem areas. Once the repairs are completed, further tests should be performed to confirm the functionality and integrity of the electrical connections before finalizing the repair. In the 7th step of troubleshooting, the technician should now check for continuity between gauge control module 32P connector terminals number 27 and number 28. This step is critical because it helps determine whether there is a functional connection between these two terminals, which is fundamental for the gauge's operation. If continuity between these two terminals is confirmed, it suggests that the pathway is intact, and the next steps can be undertaken to rule out the sending unit or gauge control module as the sources of failure. If there is no continuity, it indicates a problem within the circuitry that requires further investigation and repair. This step is instrumental in isolating problems to specific areas, thereby streamlining the troubleshooting process while ensuring an accurate diagnosis. After all necessary repairs have been made, it is important to conduct a final verification to ensure that the issues causing DTC B1176 have been effectively resolved. This process begins with querying all DTCs using the Honda Diagnostic System, HDS, once more. Following this, the technician should retest the system to check for recurring trouble codes. The vehicle should be driven in conditions similar to those when the issue was first experienced to ensure that all systems are functioning correctly. If DTC B1176 does not reappear, it confirms the success of the repairs. However, if the code manifests again, further diagnostic assessment may be necessary to explore less common issues or hidden faults not previously identified. Preventive maintenance is crucial in ensuring the longevity and reliability of the fuel level sensor and its related components. Regular system checks can help identify any emerging issues before they culminate in malfunction or failures that trigger DTC B1176. This includes inspections of the wiring harnesses for any signs of wear or deterioration, which is particularly important in areas subject to movement or exposure to harsh conditions. It is also advisable to perform routine diagnostic scans using HDS to monitor the vehicle's systems for any latent trouble codes. Ensuring that the fuel gauge sending unit is kept clean and that connections are tight will also enhance the reliability of the fuel level readings. Taking these proactive steps will help maintain optimal vehicle performance and safety. In summary, DTC B1176 points to a significant issue within the fuel level sensor circuit requiring immediate attention. The troubleshooting process involves systematic checks of the fuel tank unit, gauge control module, and associated wiring to identify and resolve the causes of malfunction. Recognizing the symptoms associated with this DTC can assist in timely diagnosis, preventing unexpected issues that can impact the vehicle's performance. Conducting thorough repairs followed by proper verification ensures the reliability of the fuel level reading returned to the driver. Moreover, regular maintenance and inspections are essential in preventing recurrence of this issue, reinforcing the importance of staying vigilant against potential faults in the fuel monitoring system. Please like and subscribe to the channel. See you next time.